Hello, I'm Ted Dangelmeyer with Dangelmeyer Associates, and for this demonstration we're going to be talking about the pitfalls associated with making field measurements. A field meter like this is very commonly used throughout the industry, and yet it's the one that we rarely see people using correctly. In fact, with all the factories that we've visited over the years, we have yet to see it being used correctly. And we're going to share with you some of the pitfalls today. Some of the others, like field voltage suppression, were discussed in one of the other videos. But let's take a look at the image behind me. We have, again, a typical field meter here. You have a 0 that has to be set to null the reading for a starting point. You have different scales to use, kilovolts per inch or volts per inch, and that can make a difference in how you make the measurements. The meter must be grounded. This is one of the most common problems is people don't ground the meter or they're not grounded themselves. In fact, I'm going to put my wrist strap on now and tell you that we were sent all the way to Korea because the engineer of one of our customers did not know how to use the meter. He was reporting unusual voltages, and it turns out that he was not grounded, and the meter was giving us a false reading because of that. So you and the meter both need to be grounded, very important, and that's true for the electrostatic voltmeters that we'll be discussing as well. Today we're going to concentrate primarily on the field of view of the measurement. When you have a field meter, and it's set to the proper distance, which is 1 inch from the object, it will view a radius around it 4 times that distance. In other words, it will look at a space about 4 inches in diameter, and it will average into the measurement whatever is detected within that field of view. Very important distinction because it can give you very misleading results, and we'll show you that shortly. The electrostatic voltmeter, on the other hand, can be set to make measurements at a much closer distance. The rule of thumb of 4 to 1 still applies, but the spacing for the recommended distance on the measurement with field meters can be down to just a few 3 to 5 millimeters. So that reduces the field of view and gives you more accurate measurements on smaller objects. Very important distinction, and typically the electrostatic voltmeters are not well known, and yet they're a very powerful tool to have in your kit. They both have their place. Here you see there are 2 different types. Here's a handheld battery version, and here is a laboratory grade instrument that needs to be plugged into AC power. Now, if we're talking about this field of view, what I want to show you in a moment is a demonstration related to this. And you can see this is the test setup that you're about to see. And what we have on the right is a battery pack. There are 5 9-volt batteries. And they're connected to these copper-colored discs. So each disc is at exactly the same voltage. They're at the battery voltage, which is close to 45 volts. The silver area is a ground plane underneath it. So again, talking about the field of view, what will happen is we'll get distorted measurements if the field of view is too large. So let's take a look at the setup that you'll be seeing again momentarily. Here are the instruments that we're going to use. We're going to use the electrostatic voltmeter, the field meter, and a contact voltmeter, which will give us a contact precise measurement of the voltage. And you'll see the variation that we're going to get momentarily. Here we are comparing the measurements that we're getting on the large disc versus the small disc. Now, as I make the transition now to the demonstration, decide for yourselves what kind of variation we're likely to see with these different instruments. I'm going to start with the field meter, and we're going to do this demonstration real time. And I have previously zeroed this meter, and you see it's grounded, I'm grounded. Very important, as I said earlier. Now, what I'm going to do is I'm going to hold this meter at the appropriate distance, which is about an inch, or it actually is an inch. And we're going to get to see that measurement now. We're getting 35 volts on that disc, on the large disc. Now what I'm going to do is measure this smaller disc. What do you think will happen to the measurement? As I come down and I measure at the same spacing, we're now getting 17 volts. Why is that? Well, it's because the field of view includes the ground plane around that disc, and therefore it's altering the measurement because of that influence. Now let's measure the small disc and see what we get here. Here we're getting only 5 volts, which follows for the same reasoning. We're picking up a large ground plane and a smaller object at the battery voltage. Now, if we do the same test with this electrostatic voltmeter, let's see what we get for readings. I'm going to come into the large disc. Let me get this where you can see it better. I'm going to bring it in here, and we're getting 45 volts on the large disc. Now I'm going to measure this medium-sized disc. We're getting 44 volts. And then on the small disc, hold it steady here, we're getting 41 volts. Very comparable measurements on all three. So you can see that because this measurement can be made at a much closer distance, the field of view is confined, and therefore it can make an accurate measurement even on these different sized discs. Now let's compare it to a contact voltmeter. This is a different instrument where we can actually measure the voltage. And we're going to start by zeroing the meter. Here you can see that we're getting 0 volts, and so the meter is set properly. We go to the disc, and we get 46 volts exactly. We go to the medium-sized disc, 46 volts exactly. And then on the small disc, exactly the same reading, as you would expect. So you can see the comparison here is that the field meter was much more greatly influenced by the field of view than the electrostatic voltmeter, as confirmed by the contact voltmeter. Very important lesson to learn when you go out in the factory. There are many occasions where you can use this field meter and get very misleading results, such as you see here. There's a tendency to overlook this phenomenon and make some significant errors in the measurements that you take. And thank you. That concludes this demonstration.